if we're going to just do basic logs. Now, a lot of these rules, like 4 to the x squared is 4 to the x squared, rewrite it on the base derivative of the exponent, itself is pretty easy. And then they throw it into a product rule or a chain rule or a quotient rule, and you need to just know those for the basic f prime or g prime. Yeah. So, same thing here. So if we're given the derivative of a log, let's say a ln in first. So let's just do the ln x, absolute value of x. When you do the derivative of a ln, what you do is whatever's the hex beside your ln, you put in your denominator. So I'm going to get 1 over x. And then you multiply by the derivative of that. So what is the derivative of x? You multiply by the derivative of the inside. What's the derivative of x? 1. So it's technically just 1 over x. I'm not joking, that is it. Okay? You guys try this one. Y equals ln x squared plus 2x. Go. Side note. Remember when we did, these are side notes. I'm going to make myself a little side note. Okay. When we did the derivative, so d, that's really not square, but that's okay. Oh, well, they just made it. They really, this board wanted to show that mine was the square, so put a square around my non-square. Thank you, board. Okay. D over dx of e to the x. We're just going to do the exponential one. How do we do that? It's a numerical base to variable exponent. What do? Rewrite it. And then ln the base. Ln of e just happens to be 1. And then the derivative of the exponent, which is 1. So that's why we got e to the x. Correct? Okay. When it wasn't an e, we had like d over dx, let's say, of 4 to the x squared. Still numerical base to variable exponent, correct? Still follow same rule. Rewrite it. Ln the base. Derivative of the exponent. The ln didn't go away this time, correct? So a lot of the time, the derivative of e to the x, everyone's just like, it's e to the x. Or if I do the derivative of e to the x squared, let's say, we would rewrite it, and then they don't even tell you ln the base. They just say multiply by the derivative of the exponent. But really, you are multiplying by ln e as well. We just don't need to write it because it's a 1. True statement? So that's when it's an e. So I would say any numerical base to any variable exponent, you rewrite it, ln the base, derivative of the exponent. I don't care if it's an e. You still are lnning the base. It just went away. Right? We need to understand why that one still has a ln of e. So same thing here. Fun fact, when you take the derivative of a ln is a special log, correct? It is just log base e of x. So actually, fun fact, when you do the derivative of a log, which a ln is just a special one, lns, you just get whatever it is on the bottom derivative of it on top, but what you actually have as well, and I just didn't make you do it, is a ln of the base down here. But what is ln of e? 1, so it just goes away. Correct? So same thing would happen here. We'd get y prime equals 1 over x squared plus 2x, technically, times ln of e. And then we'd multiply by 2x plus 2 over 1. We agree? And so we get y prime equals, take the 2 out if you so choose, x plus 2, we're going to take it out anyways because we can get critical numbers. And then on the bottom, we would get x plus 2. Oh, crud. Nothing happened here. Nothing to see. Oh, lots to see because it's not erasing fast enough. Y equals 2x plus 1. That would have been way prettier, right? That's not going to be. X plus 2. Okay. So our critical numbers are going to come from there. It's going to be 0, -2, and -1 when we actually do next unit. Now, it is technically 1 over whatever's beside times the derivative, correct? But let's think about that in actual formula matter. So, if I have y equals ln of anything, let's say ln of x, and I do my derivative of it, what am I doing? I'm doing 1 over x, and I'm ln of e, technically. And then I'm multiplying by 1, the derivative, correct? Let's say this is x squared so that we actually have something to see. So we have x squared, and then I'm multiplying by 2x over 1. This is technically just joining this every single time, correct? So do I have to show it in pieces, or can I just know that whatever's beside the ln goes in the bottom, ln the base, and the derivative of it technically goes on the top, technically, right? Because if I'm just doing a 1 on the top always and I'm multiplying by that, that's joining the top every single time. So it's a lot faster to just say, write what's beside on the bottom, ln the base, derivative of it on the top, instead of going 1 times whatever. Okay? So, let's look at 3. Y equals ln of 2x cubed plus 4x squared. What the? Okay. Go. All right. We would get y prime equals, go away. That goes on the bottom, 2x cubed plus 4x squared. What goes beside it technically? Ln of e, ln the base. And the reason why I show that is because everyone's really good with lns and they forget there's that ln the base, and then I give you like a log 5 and you forget ln of 5 at the bottom because you don't practice it. So I always just write ln the base on the bottom. Okay? And then the derivative of this on top. So what's the derivative of 2x cubed? 6x. Don't all answer at once. Squared plus 8x. And then we get y prime equals, we can do what to the bottom? And by bottom I mean top. What can we do the numerator? Take out a 2x and I'm left with? And in the denominator? 2x squared, and I'm left with? So y prime equals 3x plus 4. Okay, try this one. All right. Y prime. Sine x goes in the bottom. Ln the base. Derivative of sine x is? Cos x. The ln e cancels because that's just 1. What's cos over sine? Cotan. Done. Okay. 5. Y equals the square root of ln x. I'll say ln x squared so we get some numbers. Square root of ln x squared. What's your first step always? Change every radical to a what? Yeah, to a half rational exponent. So our y is going to equal ln x squared to the half, and no matter how much you want to take that half to put it with the x squared, you literally cannot do that. So what do we have to do here? Starts with a C. Chain rule first. Take that half, drop it to negative a half, then do the derivative of the inside. So we have to chain rule it first. We're going to go y prime, or you can go dy over dx, same thing. You get 1/2, rewrite the inside, derivative, or take a half, subtract 1, get negative a half. Then the derivative of the inside. So we need to do derivative of a ln, which we just talked about this. So we rewrite it on the bottom. Ln the base, so ln of e, that cancels. And the derivative of this x squared on top. So I get 2x. Right? Now the key thing here is that this x is going to cancel off one of those. And then I'm going to rewrite it in like this would technically be over 1. We agree? So it's like fraction, 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 right? So all the numerators, so 1 times ln x to the negative that. So we'd have ln x squared to the negative a half, which I'm going to move in a second, times 2 on the top. And then on the bottom, I have 2 times 1 times x. You cancel off the 2's, and they're going to do something else. Then move that to the bottom. Oh, my arm is not going to make it. So right here is just done. Oh, that is scary. Oh, my brain has to write. Oh, I've seen worse. Okay, we'll try it out, because this one's dead. I was only catching with this one. This one's totally fine. A game. All right. Oh. Actually, this might hurt my brain more than my hand. Okay. You can do this. You can do this. Thomas. Okay. Y equals. Ln x squared plus 3 all over 2x cubed plus 4, that's a 4x squared. Oh, I'll try. Go. So, the only difference if I gave you like log base 5, what's the only difference that would happen? If I gave you log base 5 instead of ln, you get a ln 5 on the bottom and it wouldn't go away. It's literally it. Like, there's nothing different. Okay. So this one is ln of what's in the bracket. Now a lot of people think it's chain rule or something. No, it's just ln. And if it was like, if this is overwhelming, think, okay, what would I do if I had ln of x? Oh, I would write the x on the bottom, ln of e, and then write the derivative of x on the top, correct? So if you think about it as more simple, well then that same thing would happen here. For my y prime, I would get this in the denominator. And then ln the base, which becomes 1. And then the derivative of that in the numerator, right? So if it's overwhelming because it's weird, and you're like, I don't know what to do, think of it, okay, well, if this was ln of x, what would I do? Oh, I would just draw the bottom ln of e versus on the top. Okay, so think of it in a more simplified version. So the derivative on the top is quotient rule. So I have f, I have g. F prime is 2x. G prime is 6x squared plus 8x. So I'm going to get g f prime minus f g prime all over g squared. Right? It's just your quotient rule on the top. Okay, you can do this because f prime and g prime are not chain rules, right? If f prime and g prime are chain rules, then you know that you're going to GCF stuff out right away, because chain rules will always have the same thing, correct? Our f prime and g prime don't have chain rules, and I didn't reduce that g prime to 2x, 3x plus 4. So if they're not chain rules, you can always distribute first, collect like terms, and then take a GCF out, right? Not a big deal. If they're chain rules, you must take GCFs out or it gets really complicated because you're going to have something squared or it's crazy, right? But if there is no chain rule, sometimes it's just easier to distribute and then take out something. So I'm going to get on the top in the numerator, I'm going to get 4x to the 4 plus 8x cubed. And then whatever I distribute in these brackets, the sign is going to change because I'm subtracting. Yeah, so all of them become negative because they were all positive. But anyway. X squared times 6x squared is 6x to the 4, so I'm going to minus 6x4. And then x squared times negative 8, x squared times 8x is 8x cubed, so I'm going to get negative 8x cubed. 3 times 6x squared is 18x squared, so I'm going to get negative 18x squared. And then I get 3 times 8x is 24x. That should be minus. All over 2x cubed, 5 please, 4x squared squared. And then technically it's divided by, remember when we have stacked fractions, you can write them sideways instead. X squared plus 3 over 2x cubed plus 4x squared. Collect like terms on the top. I'm going to get 4x to the 4 minus 6x to the 4 is negative 2x to the 4. These cancel. Minus 18x squared minus 24x all over 2x cubed plus 4x squared squared. And then multiply by the reciprocal, correct? Two x cubed plus 4x squared. That one cancels off one of those. And then we could take a what out? Negative 2x, which you could have taken out in the beginning, right? Sometimes GCFs are harder, so if it's not a chain rule, I'll just leave them in and take it out the very last step because it doesn't seem as overwhelming. Up to you. So we're going to get positive x cubed plus 9x plus 12 all over 2x cubed plus 4x squared. And x squared plus 2. Yeah. Yep. That would be smart. Oh, it'll be easier to do this, hopefully. Okay. Miley asked if we could take a 2x out of the bottom, which is a good idea. Because it can reduce. Squared, Crystal, 2x squared. Wait a minute, get in the game. Alright. X plus 2. That cancels that, that cancels that. And I want to go over one last thing. What if it's not ln? What if it's log? Yep. Sorry. Yeah, because we're going to want to do critical numbers in the next unit, so we want them simplified. Because we'll just say x equals 0, x equals negative 2, x equals plus or minus root 3. So to put them together, you're going to have to pull them back apart. Okay. What if I give you something like this? Log base 3 of x squared plus 6x. Still just a log, correct? The only difference is ln e doesn't go away because it's not ln e. It's ln what? 3. Okay. So we're going to get x squared plus 6x in the bottom times what? Ln of 3. And in the top, 2x plus 6. What could we do? Take 2 out of the numerator and an x out of the denominator. And we can take the x out of the denominator because this isn't squared or cubed or 4, you know what I mean? Like, remember if it was x squared plus 6x to the 7, a lot of you guys want to take an x out or whatever, you can't do that. You can only do it when it isn't to any exponent. It's just a plain old bracket. Also, what we can ask for is slope of a tangent and give you a coordinate, or a tangent equation, or a normal equation, normal line equation, right? I just have to give you a coordinate. So these are all general tangent slopes, but if I give you a coordinate, you get a specific tangent slope. Okay, your homework. And I'm giving you lots of time, so you should be productive. Hint, hint, nudge, nudge. I don't wanna.